if we're going to start talking about surface area, we're going to first probably determine, well, what in the world is the difference between surface area and volume? What is the difference between area and volume? Area versus volume. Eminal?
Area measures length and width, and volume measures length, width, and height.
Kind of.
Oh.
That's how we calculate it.
Oh, okay.
But that's not what it's measured in.
Measured in, or?
Well, I mean, what's the differences? I don't need what it's measured in, but that's what Eminal was telling me.
Volume is for 3D objects, and area is for 2D.
Now, I would agree, but there's an area of this 3D object up here. So volume goes with 3D, I agree, but area goes with both 2D and 3D. So that's why I don't 100% agree with you on that. I know what you're thinking, but I just can't agree with how you said it. Did you have something? Thomas?
Volume has depth in it, and area doesn't.
Not necessarily, because depending on how we look at area, it could have quote-unquote depth. Say we go length and depth or something. Depends if you're talking about depth as having thickness. Because some people talk about depth as how far away something is. So, answer me this. Can I talk about how much coffee I have in terms of inches?
No.
Could I talk about it in square inches?
Yes.
No.
No, wait. No.
Square inches is how much space something covers, right? How much flat space it takes up. So we could talk about the amount of carpet in here in square inches. But if I wanted to talk about the amount of coffee that I have
You have to talk about it in cubes.
in something cubed, because it's how much physical three-dimensional space it takes up. Area is flat space. Volume is three-dimensional space. Length with height, like Emerald was saying, it involves length with height, but as Bunger Photo said, it involves something cubed, some measurement cubed, because it's been times itself and times itself again. So when we look here at this big cube, let's say we have an artist with this cube and we're trying to paint it. Or sorry, not paint it, we're going to polish it. It takes me 10 minutes to polish that one square right there. Could I figure out how much time it's going to take me to polish the entire thing? I'm going to give you guys probably about a minute and a half. You can work with your neighbors. I want to see if you can figure out how long it's going to take to polish the entire cube. Just be easy to yourself and work it in minutes. We'll give you about 45 more seconds. I hear a lot of good work happening.
Didn't you just tell us like square? That's right.
This small square takes 10 minutes to polish. No, so that small square takes 10 minutes to polish.
Okay, so they don't have to
10 seconds. 5, 4, 3, 2, 1. Oh, I will in a second. Cassie. Well, hang on to it for a second. When we look at this cube, we see one measurement given to us. We see 5 feet. What does that really tell me? Every edge of this cube is 5 feet long. So this would be 5, and this would be 5, and that would be 5, and that would be 5, and all of these would be 5. Now that small square that we polished in 10 minutes, what area does that small square actually take up?
5 feet.
That small square this little square right here. It's a 1 by 1, right? So that is 1 square foot, or 1 foot squared. You can flip around your label and it still says the same thing. Now, Zach, I heard your group having some really good discussions. What method did you guys take to try to solve this?
We found the area of one side.
So how'd you do that?
We did 5 times 5.
So if they found the area of this side of the cube first, Zach says they did 5 times 5 to do that because it was 5 long on each side. What'd you get for that?
25.
25, and we'll label that feet squared. What'd you do then?
We multiplied it by 10. Wait.
Ooh. How many faces are on the cube? Because you just found out one of the faces. 6. So notice a cube has 6 faces that are all squares. So we're going to take that value and multiply it by the 6 faces. Which, guys, remember, we don't call them sides now. We say edges and faces. The faces are the flat parts. The edges are the lines between them. So we get 150 feet squared total. But that does not answer our question. Cassidy?
I know what to do.
Okay, what do we do now?
Okay. So what you do is you multiply that by 10 because it takes you 10 minutes
Yep.
to do each one. And I have the answer.
Because it takes us 10 minutes for every square foot, we have 150 square feet. So really, I could replace that square feet with 10 minutes because every square foot takes 10 minutes. So we multiply that by 10, we find out that the final is 1,500 minutes. Did anyone convert this to hours? We just divide by 60, right? Because there's 60 minutes in an hour. So this would actually equal how many hours? 25 hours. Guys, that's literally over a day. If you did this no stopping, the same pace all day long, it would literally take you over an entire day. So what might you do if you are like Huckleberry Finn to make this job get done faster? No, Huck Finn does not get a spray paint. Ask your friends. Convince them that this is oh so fun and they should help you.
What if you don't have any friends?
Yeah, sorry, I had to pull in Huck Finn. So guys, that's essentially what we're looking at here today. The first thing we have to discuss is the net of the shape. So what is the net of the shape? And most of us know this. We talked about this before. Eli?
It's a bunch of squares.
Not always. What is the net of a shape?
Oh, just
Not a cube, but what's the net of a shape? Isaiah?
Like if you unfolded a 3D object, it will like flat face.
If we cut it along the edges, any three-dimensional object can be broken up into its two-dimensional faces. So we talk about these with 2 different names. We talk about them with lateral area. And of course, I think Digits is being a little goofy this morning, so give me a second.
I'm a white phone though.
So what I want you to write down for lateral area by your, I do not want to sign this, go away. Right here on your notes. It says, is the sum of the areas of the lateral faces. What are they really saying? Lateral faces. What do we? It's not good to define something with the same word. So how can we replace that with something different?
Horizontal.
Yeah. But depending on how we turn the shape. Thomas?
No, it's gonna say vertical.
Alright, I keep writing kind of sloppily. So I guess we can, sure, we'll switch and say faces. The faces around the object top and bottom? Notice that the picture here for the lateral area, they're not including that bottom square and they're not including that top square. They just have the left, right, front, and back. So over here on your image, label like left, back, right, and front. Notice we don't have a top and we don't have a bottom. We've got the left, the back, the right, and the front. The left and the right will never be attached to each other because notice the left side over here and the right side over here, they're not attached to each other, so that's why they're never going to be attached to each other. So then when we talk about the entire surface area of something, we're dealing with the lateral area and what else? What didn't we count the first time? What did we not include in the lateral area? The bottom and the top. So now when we go from lateral area to surface area, we've got the entire lateral area, but we've also got 2 times the area of the base. Now why would I do 2 times the area of the base? Brown, is that a hand or are you stretching? Why would we do 2 times the area of the base? I think I just talked to you, Thomas.
Because the top of the face and the bottom of the face are the same.
The top and the bottom will always be identical in a prism. So over here, I want you to jot a note that a prism, top and bottom, are identical. A prism's top and bottom are identical. That's why we can just say 2 times, because they're the same thing. Did you steal that pencil from me last week?
No.
I'm missing one.
How do you know when you're missing a pencil?
Because I don't have very many. Because I keep track of them. I normally have one in my pocket, and I have a few in here that I know of. Alright, so that's why a cube is super duper easy. What do we know about a cube that makes it a very special prism? Because a cube is a prism. Remember, a prism is not necessarily a cube, but a cube is a prism. Brennan? Well, don't say sides. All faces are the same. So, since the surface area of the cube is going to be the sum of all the faces, they're all the same. So we just use 6 times the area of the face. And that's how we get our formula for the cube. So if we have a cube, all you have to do is find one of the faces like we just did in our warm-up problem and multiply it by 6. Any questions? You guys want to do these together or you want to try them on your own? Let's do one together. I'm going to leave you the cube. This first one, since it's a prism, go ahead and write up there that surface area is going to be lateral area plus 2 times big B. Capital B. You've got to use a capital. That stands for area of the base. So you might want to make a little label that this is base area.
What does L stand for?
Lateral. Lateral means around the sides. What's a lateral in football?
I don't know.
What do you do when you perform a lateral?
I just remember like the bars on the left.
You throw the ball to the side, right? Lateral means the sides. So, here's the easy way to find lateral area. Here's the easy way to find lateral area. We're going to do lateral area. I don't know why it split right there. We're going to do lateral area as the perimeter times the height. And here's what I mean. That perimeter is the perimeter of the base. And if you look a little bit higher up on your paper, this formula is up there. So if you look right up here, and if you didn't highlight it or circle it or something, I would. Right up here, here's your lateral area formula, perimeter times height of prism, perimeter of the base. So I set up my lateral area. I'm going to restart so I have some extra room. My perimeter of my base, well, I look at what my base is. I've got a 9, a 2, a 9, and a 2. What do you think the perimeter around that base is? If I've got 9, a 2, a 9, and a 2.
18.
Close. 22. My perimeter around here is 9 plus 2 plus 9 plus 2 is 22. So my lateral area, being perimeter times height, becomes 22. Now the height that we use is always going to be the distance between bases. Because watch this. Give me your eyes up here real quick.
Okay.
Hexagonal prism. If I lay it like this, what shape is the base? No.
Rectangle.
The direction the shape is facing does not determine what the base is.
Oh.
Hear me when I say this. This is the biggest mistake I've seen my whole time teaching this. What kind of shape am I holding? What is its base? A hexagon, no matter what. It can be facing like this. It can be facing like this. It can be facing on a corner sideways. And its base is still a hexagon because it's in the name. You determine the base of a shape by what is in its name. Do not care about what direction it's facing. So, any of these, they're rectangular prisms regardless of which way I look at them. It's once we move beyond the rectangular prisms that things get more complicated. So, I use my perimeter of my base. It's my rectangle. So my height is the distance between the bases. Your height's always going to be the dimension you haven't used yet. I used my 9 and my 2, my 9 and my 2. I used those. I haven't used my 3. That's my height.
Why didn't you just do 9 times 2 plus 2?
What? Oh, yeah, you can. Because you could do length plus width times 2. I mean, there's a lot of different ways. I just showed it out like that to just show what we were doing. So, my lateral area becomes 66 feet squared. Because remember, it's area. We got to have a label on it. Then I need to find out what's the area of my base. Well, remember, my base, I already determined, is what I drew green around. I'm using that big rectangle as my base. So to find the area of this guy, how do I do it? 9 times 2, right? So 9 times 2, that. And actually, I'm going to label that big B for the area of the base. That's going to be 18. So now to find our total surface area, it's the lateral area plus 2 times the big B. So that will be my 66 plus 2 times 18. 2 times 18 gives me 36. And this, when everything is all said and done, comes out to be, if we have not made any mistakes, 102 feet squared. My doubling of my... That's where it came from. I do my lateral area, which I already found was 66. My big B I found was 18. I have to double that once I put it in the formula. So I'm kind of color coding to help you guys see where everything follows through. Any questions on how we found that lateral area? Thomas?
Why did we need to find the perimeter first?
So, good question. You could work it face by face by face. You could just do each face individually. But check this out. If I make So this is my top, right? So we're not going to worry about that. So I'm going to fold that over on itself and kind of try to make it disappear. If I look at my lateral faces, these 4 faces around here, right? They all share the same height. Can we agree on that?
Yeah.
When I unfold them and I look at what makes up the area pieces, and it actually can work better if I use not a cube. Let's use this hexagonal prism since we were referencing this. So my top, I don't care about, forget about it for the moment. My lateral area, these rectangles all the way around, right? These sides that are not the bases, they all share the same height. But then when I go to look at what will the lateral area be together, it's one rectangle. This bottom length of the rectangle is determined by the perimeter of the base, because when I unfold these, their total length is just the total distance around the hexagon. So by doing that perimeter, I essentially find the length of the rectangle, and then I multiply by the height to just find the area of the rectangle. Same thing happens if I grab my pentagonal prism. I've now got 5 rectangles all the way around the side, but if I unfold them, it's just one big rectangle. So the bottom here is the perimeter of the base, and then times the height, I have one big rectangle.
Oh.
Does that help? If you're watching the video, that probably won't make as much sense since you couldn't see what we were doing. That's why I want to integrate the webcam occasionally. Try the next 2 on your own. So try to use the method that we just talked about, perimeter of the base times the height for that lateral area. Who's confused? Okay, I'm coming to help. First thing we want to do is determine what's your base. Here, we can just say the side on the bottom, that's the base, right? Because it's a rectangular prism. My second one here is actually really easy because it's a cube, so we're going to jump past that for a minute. Let's move all the way over to the right, this far one. Draw a box around your base, around that rectangle, the bottom side. Yeah, like around it. So we want to draw right here. Just to think about what is it, and we can even shade it if we want. We say, okay, that's my base. So then when we look at that perimeter, we've got a 6, a 1, another 6, and another 1. So add up your 6 and 1 and then double it. So what's 6 and 1? 7, double that. 14. That's your perimeter of your base. So when I unfold that shape, that's how long all of those rectangles together will be. Then how tall are they? 9 feet. So to find that lateral area, we're just taking 14 times 9. Yeah, try to do all of them. Answer? Let's do a whole group, and then if you still have questions, then you can take it. So come back together wherever you are in your work. Bless you. My cube is easy. You can use the same formula, the lateral area plus 2b. You can use that for the cube, or you can just do 6 times s squared. Now what's s squared really telling me to do? Square the side length, which really, I'm glad that Thomas just said what he did. It's really the edge. So you can also say that 6 times the edge squared. The only reason we don't necessarily use that, E is a mathematical constant. It is a value, like it has a number that goes with it. So if you use it here, just remember you're talking about edge. You're not talking about the mathematical constant. You're talking about the edge.
What is the mathematical constant?
We'll get into that later. It deals with finances and when you take a loan over a long amount of time. So my edge length here is 3. My 3 squared, what's 3 squared? 9. What's 6 times 9?
54.
54. So my final surface area becomes 54 feet squared. Guys, you gotta have these labels. You gotta have these labels here. Hey, Divine, where you going, man? Yeah, can you wait like 5 or 6 minutes so we can get through a little bit more of the lesson? You just told me that you were confused on this stuff and you're gonna leave while I'm going over the problems? Like that doesn't make sense for you trying to learn it, right? So just hang out for a few more minutes. When we're doing the perimeter of any rectangle, you know you have pairs of sides, pairs of matching lengths. So we can just say, okay, what's the 3 plus the 2, and then double it. What's 3 plus 2? 5, then double it, so that gives me a total perimeter of 10. Now the height here will be that 4.2. 4 1/5 is going to be 4.2. So my lateral area will be that 10 times 4.2, which is actually 42. I'm going to circle that because it's part of my area. I'm going to use it in my area. And I'll label it when I get to the end. I then want to find out my base, my big B. Well, we already said that our base is this 3 by 2. So what's the area of a 3 by 2? 6. And I'm going to use that in my formula. So then when I get down here to do surface area is going to equal that 42 plus 2 times the big B. One of the biggest mistakes I see people make is they forget that it's 2 times your big B. So 2 times my big B was 6. This becomes 42 plus 12. And in final, it's 54 feet squared. Yep.
Yes.
So notice, those are 2 different shapes. 2 different shapes, but they have the same surface area. 2 different shapes that have the same surface area. So now the question would be, which has the bigger volume? Because if so, one of those might be a better choice for packaging than the other one. Now on our last shape here, I've already got written out here how we find our perimeter. Add up your 2 sides and then double because we know we have the same thing in the back and the same thing on the left. So what's my perimeter become here? 14. So then my lateral area will be that 14 times what?
9.
Times 9 because that's my height from base to base. What's 14 times 9?
126.
126. I'm going to circle that because it's important. I'm going to need it. What about my big B? I'm just going to go ahead and write in my shape. 6 times 1, so my big B is just 6. I'm going to have to double that eventually. So now down here in my formula, surface area equals the lateral area of 126 plus 2 times the big B. Notice, guys, that I have my needed formula right up here. Always have the formula that you're using written down somewhere so you can reference back to it. So then 2 times 6 is 12. 126 plus 12 is going to become 138 feet squared. We always got to have the label. Questions, comments, concerns? If you need to go now, you can.
This is one of the easiest topics for me.
So you guys know, we are going to try to get through this chapter this week and take your mastery on Monday. I don't like Monday masteries, but next week's a 2-day week. So, and then if we get done with your mastery Monday, we'll do Mind Trap on Tuesday. If we don't get done with your mastery, we'll just finish your mastery on Tuesday. Mastery deadline's Wednesday. Grade cutoff already happened. Yeah.
Wait, grade cutoff already happened?
For most classes, I mean, to my knowledge, yes.
Yeah.
Yes!
These are really stressful.
That's great.
Try this. What about when they don't give us a picture? If they just tell you, hey, it's a cube and its edge length is 3/4 of a foot. Now be careful. 3/4 of a foot, less than 1. Numbers that are less than 1 start to get a little weird. Do the math written out. Do not use your calculator. So if you have it in your hand, put it down. Surface area of a cube is 6 times that edge length squared. So that edge length squared is 3/4 times 3/4. I'm not going to make it a decimal because a decimal is more annoying.
Is it 9?
Here's
It's 9 inches. 3/4.
Nope, you're close.
8. No. 10. It's 70.75.
Stop trying to think about decimals. Trying to use decimals in feet is really, really bad because feet is a base 12 because there's 12 inches in a foot. So, guys, fraction times a fraction is easy math. Straight through top, straight through bottom. What do we get here?
It's 9/12, which can be.
Ooh, close. 9/16. Now what I'm going to do is actually make my 6 into another fraction, so I can do another fraction times a fraction. But before I do that, I can cross reduce. I see that my 16 and my 6 share the fact that they're even. So I can divide them both by 2. This becomes 3. That becomes 8. 3 times 9?
18.
27. 1 times 8? 8. Wow, this is terrifying. I get that it's Monday, but guys, think before you open your mouth. And I'm not talking just in math class. In general, think before you open your mouth.
I'll take the
27. Hey, hold up. 27 over 8. We can simplify this. 3 and 3/8 left over. Because 3, think about it. 8 times 3 is 24. So then I have 3 left over. So then I can make this feet squared. That's it. That's all the math you have to do. Yeah, that's why I said put down the calculators. This is all basic math. Like for cubes. It gets harder with prisms, but cubes are pretty basic math.
Are we going to get into cubes or prisms?
Yep. So now we have Misadventure has been traveling around the world. She kind of reminds me actually of Miss Yasik. You guys want to see Misadventure?
Yeah.
Here, Misadventure is, I think it's part 2.
Oh my god.
She does look like Miss Yates.
I think mistakes that big.
So, let's say she was in the Netherlands eating some Dutch cheese. So, this cheese, to determine the base, we always have to say what face has the identical face directly across the shape. So if you look at how this is sitting right now, it's kind of easy to figure out. The triangle's on the bottom, there's a triangle on the top. But some people will try to say that this is the base. It can't be because there's not another rectangle on the other side. So when you have to determine what the base is, you have to look for matching shapes. I have a triangle on bottom here, And I have the same triangle on top, even though my drawing is not very good. So since I've got the same triangle on top and bottom, this is a triangular prism. So a piece of cheese has a shape of triangular prism. How much surface area is there for the mold to grow on? Cheese is mold, by the way. Casey didn't know that.
It
Yep.
is?
Cheese is mold.
Yeah, you didn't know how cheese was mold.
So let's set up our formula. Set up your formula right up here. Hey guys, with me. Right up here. I want you to write out surface area equals lateral area plus 2 times the big B. Then we can also say that lateral area equals the perimeter times the height. So we need to determine what is this perimeter. Do we know this edge of the triangle?
Yeah.
What is it?
14.1.
Ooh, that's the height.
It's 15.
So this is actually 15. And this right here tells me that this edge of the triangle is also 15. What about this edge on the bottom? 10. So what's my perimeter around that triangle?
15 plus 15 plus 10.
Yeah. So 40, right? 15 plus 15 plus 10 for that base shape. Now the height. Hey guys, as I look around, I know who's not writing this down. So write it down.
Okay.
Yeah.
14.1.
Ooh, that's the height of the triangle. Remember, the height of the prism is the distance between the matching bases. So it's this distance right here, 6.5. So my lateral area, break it up. 40 times a half. Well, that'd be 20. 40 times 6, think of 4 times 6, 240. So then this comes out to be 260 total for my lateral area.
Don't you need
That's the lateral area. Because that was our perimeter times our height. So that was our lateral area. So that's the area around the cheese. We also now need to look at the bottom and the top. So now if I'm going to look at the area of this shape, that's why I'm going to color in the inside with a different color. My base area, how do I find area of a triangle? Is there?
Base times half divided by 2.
Yeah, so we normally use the formula half the base times the height. Notice I'm using little b. We now use little b because it's the base of the triangle. What's big B represent?
Base is a shape.
It's the area of the base of the shape. Big B is always the area of. So, for your triangle, what's the base edge of the triangle? Well, if I look at the triangle being right here, what's the base edge? 10, because remember the base of the triangle has to be perpendicular to the height. So because I see this right angle right here, I know that that's my base and that's my height. So my base is 10. My height is that 14.1. And they just had to make it 0.1.
How would you explain little b again?
Little b, just the base of the triangle. So then, this is 1/2 of 141, because 10 times 14.1, that's easy. I do that first. So then, big B actually comes out to be 70.5. Are we getting all this math written down, or are we just kind of playing with each other's hair? Okay. This is easy to make mistakes, guys. So I'm kind of being a pain this morning. Then we got to set up our whole formula together. So my surface area is going to be the lateral area that I found, 260, plus 2 times my 70.5. Now wait a minute. I did half of something to get my new something, and then that new something is going to be multiplied by 2. Yeah, I could have just stuck with my 141 instead of doing half and then 2 times. I could have just said, hey, 2 times the base is 141. So we could have here, instead of doing 2 times 70.5, we could have just used that 141. And those are the shortcuts that only practicing will help you be able to identify. So our surface area in the end
It's 401.
becomes 401
Feet squared.
feet. Not feet.
Feet cubed.
Nope.
No, I-
Check your label. Centimeters squared. Questions, comments, concerns?
Don't call me stupid right now.
What is the base of the next shape you see in your notes? What is the base?
Rectangle.
A triangle.
I meant to say triangle.
Oh, hold on. That's really bad. That didn't capture in time.
Whoa, that's so
That was.
That's cool.
There we go. Always look at the name of it to determine what the shape is. It looks like we're probably going to need to finish this tomorrow. There's too much for us to just move on. So, work on your homework tonight. Whatever you cannot finish, please bring questions to me tomorrow. Yeah, so tomorrow we might just finish the lesson and then finish the test.
Said you're missing a pencil. Win it.
No.
I found this one on the floor.
I'll take it, because then I can learn more out. It actually has lead, too. Interesting enough. Thank you very much.